Have you ever looked up at the night sky, filled with countless twinkling stars, and asked yourself a very big question? It's a question that people have wondered about for as long as we have been able to look up and dream. Are we alone? Is our beautiful, vibrant planet Earth the only place in this enormous universe where life exists? It's a thought that can make you feel both incredibly special and maybe a little bit lonely. This isn't just a question for science fiction movies, it's one of the most profound and important questions that scientists, explorers, and thinkers are trying to answer today. The idea of finding life somewhere else is exciting, mind-boggling, and could change everything we know about our place in the cosmos. This question sparks our imagination like nothing else. Think about it. If we found even the tiniest, simplest form of life, like a little microbe wiggling around in the soil of another planet, it would be one of the most significant discoveries in all of human history. For thousands of years, people from every culture around the globe have looked up at the same stars and wondered what was out there. Ancient civilizations told stories about gods and spirits living in the heavens, creating myths and legends to explain the mysteries of the sun, moon, and stars. They didn't have powerful telescopes or spaceships, but they had powerful imaginations. They drew constellations, tracked the movements of the planets, and built incredible structures aligned with celestial events. This shared human experience connects us through time and shows the desire to understand our place in the universe. When early astronomers like Galileo first turned a telescope toward the heavens, they made incredible discoveries. They saw that the moon had mountains and craters much like Earth. They realized that the planets in our solar system were worlds in their own right, sparking the idea that they could have life too. Stories by H.G. Wells and Jules Verne imagined journeys to other worlds and captured the public imagination. These tales helped build cultural excitement that supported real space exploration. We have images of astronauts on the moon, rovers exploring Mars, and breathtaking photos from space telescopes. Today that wonder is stronger than ever. The idea of space is no longer untouchable. It's a place we can visit, study, and explore. Every new mission and discovery fuels curiosity and inspires a new generation of engineers, astronomers, and explorers. The timeless human quest continues, to find answers among the stars. Let's carry that wonder forward as we look at the size of the universe and why that makes the search for life so exciting. To truly grasp why the search for life is so exciting, we first need to understand just how incredibly big the universe is. Let's start with our own galaxy, the Milky Way. Scientists estimate that the Milky Way contains somewhere between 100 billion and 400 billion stars. That's not a million, but a billion. If you tried to count them one by one, it would take you thousands of years. Each of those stars is a sun, and many have their own families of planets. Now let's zoom out even further. The Milky Way is just one galaxy. Hubble has looked into the deepest patches of sky and found them filled with galaxies. Latest estimates suggest about 2 trillion galaxies in the observable universe. Let that number sink in. 2 trillion. Each galaxy has billions of stars. Multiply galaxies by stars and the total number of stars is beyond easy comprehension. It's more stars than grains of sand on all Earth's beaches combined. If most stars have at least one planet, that means trillions upon trillions of planets across the cosmos. With so many chances, it seems more likely the right conditions for life could appear more than once. Imagine searching for a blue marble on a vast beach. The bigger the beach, the better the odds of finding another blue one. The universe is that giant beach. With almost infinite worlds, it feels less like if life exists elsewhere and more like where and when we will find it. So, how do we actually look for life on other worlds? Scientists have become cosmic detectives using amazing tools and clever methods to search for clues. One method is to send robotic explorers to our planetary neighbors. Missions to Mars are a perfect example. We have sent rovers like Curiosity, Perseverance, which are like robotic geologists on wheels. They drill into rocks, analyze soil, and take detailed pictures searching for organics and evidence of past water. Another key method is listening. Far out in space, advanced civilizations might be sending radio signals, laser signals, or beacons on purpose, or leaking communications like our TV broadcasts. Scientists use enormous radio telescopes, giant ears pointed at the sky, to listen for unnatural patterns. This effort is known as SETI. It's like trying to tune into a cosmic radio station. Beyond our solar system, distances are too vast for rovers. We use space telescopes like the James Webb Space Telescope to study exoplanet atmospheres. When a planet passes in front of its star, a bit of starlight shines through its atmosphere. By analyzing that light, scientists can identify gases, potential biosignatures like oxygen, methane, water vapor, gases that on Earth are often produced by living things. Rovers, radio telescopes, and space telescopes are different but complementary. Each method has challenges and rewards, and together our cosmic detectives cover as many bases as possible. When scientists search for life, they often start by looking for planets that have the right ingredients, like a recipe for a habitable world. The most important ingredient is liquid water. Every living thing we know of, from the smallest bacterium to the largest blue whale, needs water to survive. A key part is finding planets at the right temperature for liquid water. Not so cold it's all ice, not so hot it all boils away. Scientists call this the Goldilocks zone, the orbital region where surface temperatures can support liquid water. Too close like Venus is hot, too far like Mars is icy. Earth sits in our sun's habitable zone with oceans that support life. Besides water, life needs energy. Most life uses sunlight via photosynthesis, but some life uses chemical energy. Deep-sea hydrothermal vent communities show life can thrive without sunlight, powered by chemical reactions. That means life could exist in dark, subsurface oceans on moons like Europa and Enceladus, powered by heat and chemistry. Finally, a planet needs the right chemical building blocks. Life on Earth is carbon-based and relies on elements like hydrogen, nitrogen, oxygen, phosphorus, and sulfur, essential components of biology as we know it. These elements are forged in stars and scattered when they die, so the ingredients for life are common across the universe. So the basic ingredients are likely available on countless worlds, just waiting for the right conditions to come together. For a long time we only knew planets in our own solar system. That changed in the 1990s with the first confirmed exoplanet discovery. Since then, observatories like Kepler have found thousands of exoplanets. The number keeps growing. Hot Jupiters, super-Earths, and Earth-sized planets in habitable zones, all kinds of worlds exist. One famous system is TRAPPIST-1, about 40 light-years away, with 7 Earth-sized rocky planets orbiting a cool star. At least 3 or 4 are in the habitable zone. Imagine traveling from one potentially life-bearing world to another in short order. TRAPPIST-1 is a prime target for JWST to search for atmospheres and signs of life. The discovery of exoplanets shifted the question from philosophical to statistical. Planets are everywhere. Rocky Earth-sized worlds are not rare. That knowledge fuels optimism and gives concrete targets for study. We're not just guessing anymore. We're mapping and studying these worlds for signs of life. Every new exoplanet is another lottery ticket in the cosmic hunt. The search is becoming practical and data-driven. With billions of stars and planets, it can feel like finding life should be easy. Scientists use tools like the Drake equation to think about the problem. The equation multiplies factors: rate of star formation, the fraction of stars with planets, the number of planets that could support life, and the fraction of life that becomes intelligent. We only know the first few factors with certainty. For the rest, we must guess. Depending on your assumptions, you can get answers from one civilization to millions. The real value of the Drake equation is it shows what we need to learn. It's a roadmap for our scientific journey. This leads to the Fermi paradox. In the 1950s, Enrico Fermi asked a simple question: where is everybody? If life is common and the galaxy old, why don't we see evidence of civilizations? Where are the signals, the probes, the city lights? Possible solutions range from hopeful, we're the first, to sobering, civilizations destroy themselves, or everyone hides, or distances isolate us. The Fermi paradox reminds us the silence we hear from space is itself a deep mystery, one that drives much of the scientific work today. The search for life is active science. While we haven't found aliens yet, we're finding tantalizing clues. Missions to icy moons like Europa and Enceladus have revealed evidence of global subsurface oceans under frozen shells. Plumes erupting from Enceladus give us samples of subsurface material, and mass spectrometry has revealed complex organic molecules. Hydrothermal vents could provide energy and nutrients like on Earth, making these moons exciting targets for life. Back on Mars, Perseverance collected rock samples from an ancient river delta rich in organic molecules, not proof of life but a huge step forward. Those samples will be returned to Earth for detailed analysis in advanced labs. Beyond our system, JWST detected a potential hint, a substance called DMS in the atmosphere of K218b on Earth. DMS is overwhelmingly biological. The finding is preliminary and needs confirmation, but it demonstrates our ability to sniff out biosignatures light years away. Our telescopes and instruments are now powerful enough to detect faint whispers from the cosmos, and that keeps scientists on the edge of their seats. After all this exploration and data from telescopes and rovers, we come back to the fundamental question: are we alone? The honest answer as of today is we still don't know for sure. We have not yet found definitive proof of life beyond Earth. No alien handshakes, no confirmed messages, no microbes wiggling in Martian soil. The universe remains largely silent. Earth remains the only place we know for certain is home to life, but the search is more hopeful than ever. We found planets are common, the chemical building blocks are widespread, and evidence of ancient water exists throughout our solar system. We have tools that can taste the air of distant worlds, moving from speculation to real data. The quest is a multi-generational marathon. It took thousands of years of stargazing to reach the point where we can send our robotic eyes and ears into space. The progress of the last few decades is astonishing and accelerating. The next clue could come tomorrow or 50 years from now. The search continues. Stay curious, keep learning, ask big questions, and look up with a sense of wonder. The next breakthrough could come from anyone.